Within 1 second, a snake can wave its tongue up to 15 times. It is one of the most infamous specialized organs in the animal kingdom. Snakes rely heavily on smell, a complex method known as chemoreception, to locate prey and escape danger. This dependence is closely linked to the limitations of their sight and hearing. Snakes are not entirely blind creatures. However, their visual capabilities vary greatly among species. Some nocturnal species of snakes have poor eyesight. They can only detect movement, shape, or contrast, rather than detailed images. During hunting mode, pythons or boas often supplement or even replace vision with other senses. Snakes also lack external ears or eardrums. Therefore, they are unable to hear airborne sound. Instead, they detect vibrations transmitted through the ground or their skull. Their hearing is more tuned to vibrations than sound. To compensate for poor eyesight and limited hearing, snakes evolved sophisticated chemosensory system. This is the ability to detect chemicals in the air or on surfaces, using their tongue and other highly specialized organs. A snake's tongue is long, slender, and typically bifurcated, meaning it splits into two tips. These two tips of the tongue are known as fork or tines. They are the delicate tips that sweep the environment to collect chemical particles. When retracted, the forked tongue lies in the fissured tongue sheaths at the roof of the mouth. It is a specialized structure in the mouth which houses and protects the tongue when not in use. When a snake flicks its tongue, each fork samples the environment separately. The direction in which the tongue flicks determines the side which will pick up more scent molecules. If the right fork encounters more scent molecules, the snake can discern that the source of the smell is to the right. This gives the snake a sense of directionality or stereo smell. The sampled air can identify the chemical traces left by animals, whether it is the scent of a small mammal, a bird, or even the presence of other snakes. Once the tongue is retracted into the mouth, the chemical compounds are transferred to a specialized organ located at the roof of the mouth, known as the Jacobson's organ or the vomeronasal organ, via two openings. This organ is sensitive to even minute amounts of chemicals. It sends the chemical signals to the brain, allowing the snake to interpret and form a sensory map of the environment. By flicking its tongue continuously, the snake gathers ongoing sensory data, which helps it to maintain a mental map of the surrounding area. The collected particles are chemical compounds that can provide the snake with information about its surroundings, including potential prey, predators, mates, or environmental hazards.